It's past 9.
The Radio Wammo Breakfast.
Live from the New Scientist Labs, Janine Young, newscientist.com.
Yeah, we do like to talk science around about this time on the show, and Janine Young is the perfect person to deliver it for us. Not from here in New Zealand, though, no, from Melbourne. That's because it's a connected world. G'day there, Janine.
Good morning, Wammo.
Doesn't matter where you are these days. I mean, just a few weeks ago you were in Europe.
I was, and I think my body is still on that time. I seem to be waking up around 4 o'clock in the morning. Lucky me.
Lucky you. Gosh, that means you've been up a wee while. Well, let's get into these stories. First up, now we've been hoping to have the electric car become, ubiquitous for a long time, and it seems to be slowly starting. I know that a lot of taxis here in Auckland City are electric, but what about planes? When are we going to see electric planes, Janine?
Not for a while yet, but the electric car is probably a really good starting point for where an electric aircraft is going to come from. Part of the problem with electric anything is the weight of the batteries. You put a heavy battery into a car and it'll roll along quite nicely. The same thing will happen in a plane. It'll roll, it just won't take off, which I think is a fundamental problem for an aircraft, really, if it's not actually going to get off the ground. So while the idea of using electricity is really sound, and a lot of people really like that idea, the practicalities is what's starting to get in the way. Now, NASA has come up with a Green Flight Challenge. They're going to run it around July next year. It's a competition, essentially, for an electrically based aircraft. It doesn't have to be pure electric. It can be a hybrid. There's a number of different technologies that people are coming up with. Indeed, we have some ideas that of the, I think it's 9 that have registered. 5 are saying that they're going to be dealing with some kind of hybrid. They have to travel 200 miles, which is 322 kilometres, in under 2 hours, and using less than the energy equivalent of a gallon, so that's a little under 4 litres of fuel, aviation fuel, per occupant. So in other words, they really want to try and make sure that this is largely electrically based, or at least finding some other way to power these things. Some solutions might include an engine that is partially electrically based and one that also has kerosene. It could have biofuels, although there's not that much of biofuels around to be able to fuel it. That's the problem. It runs quite happily on biofuels at the moment, but the supplies are not enough to feed the world's fleet. So you've got a bit of a trick there. But they're offering $1.5 million to whomever can fly for this 2 hours and all the other criteria that I just laid out. So that seems to be inspiring a few people to have a go and see what they can come up with. And
do we know what sort of how these aircraft are going to be propelled through the air? Is it propeller engines, or is it jet-like engines, or something completely new?
It doesn't look as though it'll be anything completely new at this point. Because we have existing technology that works, a lot of the time taking what you have and adapting it to something else is a really good way to make things work. Some piston engines, they think that what they'll be able to do is take a turbo on them effectively. So electrically stimulate them as well as stimulate. That's not the word I was after. Run.
Well, they do need to be stimulated through the air, don't they?
It's still kind of early in the morning here, and I'm just going to hide behind that right now. You run your engines. You can, for example, use all the thrust you need to get off the ground using kerosene as well as electricity. But for the actual running, so propelling through the air for a short flight, or even a longer flight, you might be able to use electricity. For a short flight, you might be able to use electricity alone. It depends on how far you're travelling and how heavy the aircraft is and how heavy your batteries are. Unfortunately, at the moment, or not unfortunately at the moment, but they're finding that for the amount of battery that would be required to propel an aircraft through the air on a long-haul flight, it'd take about 3,000 kilograms, I think it was, of lithium-ion batteries, compared to a third of the total weight of an aircraft now being fuel. So there's a big difference in what is able to be used. So they're looking at lightning frames, they're looking at a number of different strategies to be able to make these electrical aircraft possible. They're not there yet. Boeing and Airbus are both looking at how they might be able to adapt some of their fleet. Cessna is apparently going to try a few test runs next year of its Skyhawk 172. It's a bit of a workhorse, apparently, a 4-seater that is used right across the world. There are thousands of them around. So they're talking early in 2011, they're going to have a test flight of one of these running on electrical power.
Cool.
So it's very likely that the bulk of the exciting engineering is going to come out of smaller manufacturers, but the larger players are also looking at this. So, watch this space.
Yeah. All right. Well, moving right along from stimulating air travel to a whole human liver that has been built in a laboratory, Janine. What's this about?
You're not going to let me forget that, are you? I made a mistake. It happens. Yes, human livers are in short supply. A lot of people need them for transplants and the like. So a goal for a long time has been trying to make an artificial one. It's not an easy thing to do because you've got very complicated functions of very specific types of cells that need to be hooked up to blood cells. They need to be innervated. Organs are not simple things. So lots of researchers at Wake Forest University have done, Shay Soka being one of them, in North Carolina, have taken a ferret liver, washed it in mild detergent to get rid of the ferret cells, and they've left the collagen behind. It's like a scaffold, a structure. They then took human stem cells derived from umbilical cords from brand new babies, so no people cells were injured in the making of this liver.
Yeah.
There are no embryonic stem cells involved here, aside from the ones that you get out of umbilical cord cells. So there's no ethical issues there. And what they've been able to do is put these stem cells across the scaffold. They've arranged themselves where they needed to be. They put them in a bioreactor for a week, so all the nutrients and, I'll say it this time, stimulation that they need to grow and divide and actually go to where they're meant to be. And this is the first documentation of being able to engineer a whole liver with human cells. So this is potentially very exciting because it means that if they can get this right, and they are at the earliest stages, so no whole livers popping out next week for transplant, unfortunately. It could be a very big step forward in being able to construct entire livers for people who need them. So we don't need to necessarily move towards pig livers or, as many human transplants at the moment.
And this shouldn't be taken as, of course, as an excuse to go and damage your liver this weekend, Janine.
No. We advocate responsibility and moderate drinking. But livers can also be affected by other diseases, such as hepatitis and the like. So it's not just people who go out and attempt to get cirrhosis every weekend, but, there are other legitimate diseases that come along and do destroy your liver.
I like that, legitimate.
Things that you don't do to yourself.
Yeah, fair enough. Hey, Janine, thanks so much for that. Those stories, of course, people can find in New Scientist magazine, which will be out next week, and also eventually online as well. newscientist.com. We'll catch you next week, Janine.
See you later.
See ya.